Okay, so today we're going to talk about neutralization reactions. I'm just giving you the information. We're not going to apply it today. You actually will in your lab next week. Your titration lab is an example of a neutralization reaction. So I can identify an acid-base neutralization reaction. Okay, there are two key parts to this, all right, and you have to have them both, all right. First of all, you have to have an acid and a base in your reactants. Now, before we get into the second thing, I just want to give you a brief description of what a neutralization does. It's just a double replacement between an acid and a base. So we're going to switch partners to figure out what our products are. I'll expect that you guys can be able to do this, but it has the basic setup of this. Part 1, you need an acid and base in reactants. Part 2 that you have to have is that it forms in the products what's called a salt plus H2O. Okay, let me give you an example here of what it's going to look like. We'll have hydrochloric acid, and I'm going to put the AQs in our examples. I won't really care about them once we start doing the practice. Plus NaOH sodium hydroxide as our base. To me, you see your acid and your base, you got to think neutralization. One of your products is always going to be water, H2O. Write that first. And then second thing I need you to do is I need you to take a look at what switched partners. Okay, this H here went with the hydroxide to form water, so we have Na and Cl that form a new partnership. Remember, the metal Na has to go first and the Cl has to go second. Okay. Double check your charges of Na and Cl, crisscross, and that will work out correctly there, NaCl. In the state of matter, H2O is going to be a liquid. So we just put an L there for liquid, and NaCl is soluble in water, so it's AQ. Is that a reaction? Is a good question. Did my reactants change into different products? Yes, it did. So what is the answer to that question? Yes. You are being recorded. Alright. Alright. Now, here's another example. H2SO4 is sulfuric acid. LiOH is a base. Lithium hydroxide. Now, if I give you that, I expect you guys to know that it's going to be a neutralization reaction. How do you know that? And what type of substance when it's OH? Okay, we have a base. Okay. And what else do we have up there? What's going on there? When you see that, you got to think it's going to be a neutralization. Alright, so what's the first thing we're going to do to figure out my products? What is one of my products every single time? Water H2O. Write that down. Alright. How about my other partnership? Who knows what the other partnership will be now? Alright, well, Li and SO4, and then you think about your charges, I heard it, put an Li2 SO4 right there, because the sulfate's -2 charge. Perfect. Now you just got to balance it. We're going to have to put a 2 right there, and we're going to have to put a 2 right there, and we'll be balanced. Couple bullet points. The products become neutral. Which means neither acidic or basic. What's one property of a solution when it's neutral? It's not a property. pH is 7. You have a pH equal to 7. And there's one more property. We'll get to the salt form here in a second. I'm just talking about a neutral solution. Not 14. Not 14. There you go. Good job. Essence Gray. Essence Gray said that. She was exactly right. H plus equals OH minus. There's actually a number value for both. What is that number value when they're the same? No. 1 times 10. Not to the -14. 7 N. Good job, Timothy Mills. All right. Now, here's the thing. I got asked the question earlier, can we just write NaCl instead of salt? NaCl is a kind of salt. Salt is a very broader term than just NaCl. Here's the proper chemistry definition of the salts. It is a compound consisting of an anion from an acid, the negative part of the acid, and a cation from the base. So take a look at table salt is the proper term for NaCl. You're right. So lithium sulfate is a salt. And I guess we'll use that as an example instead. We got our lithium, the cation from our base, lithium hydroxide. We got our anion, the sulfate, from our acid. Okay. I want to give you a couple reminders about writing formulas for salts. You switch partners. From the acid and base. Crisscross your charges. finally, just remember the positive metal cation is always the first symbol in your formula. Okay, it is not SO4 Li2. Okay, has to be the Li first, and then the SO4. Positive metallic cation is written first. Bam. Okay. So we're going to practice 3 practice problems where I'm going to give you the reactants. Promise you they'll both be an acid and a base. That's how you know it's neutralization. You guys are going to practice getting the products. Those of you watching at home will do the first one together, and I'll expect you to do the other 3. This is from the orange textbook, page 616, number 37. I will just write it out for you. You don't have to open your books. Okay. So the first one is H2SO4 plus KOH. Okay. Make sure you balance these equations when we're done. So let's go through this one together. Alright. How do I know it's a neutralization again? Okay, acid, base and an acid. Perfect. Okay. What is one product always going to be that you can just write down? H2O. Okay. Now let's figure out our new partners. Okay. What is our new partnership? Lucas.
K2, SO4.
Look at him. He not only found the partners, he crisscrossed the charges to get K2, SO4, K is +1 and sulfate is -2. This here with that there, that's perfect. Then you just got to balance it. We'll put a 2 here, and we'll put a 2 in front of our water. Okay. Alright, here's 2 more examples that I want you guys to do. H3PO4 is phosphoric acid reacting with calcium hydroxide CaOH2. And then the last one, nitric acid, HNO3 plus magnesium hydroxide MgOH2. For those of you at home, please finish. Show it to me if you're not